Hi guys, welcome to my YouTube channel. So in this video we will be discussing about Apache Web Server internal design, right, and the architecture obviously. But before we start, right, I would request you guys to please subscribe to my YouTube channel. What I've seen is 80% of my viewers have not subscribed to this channel, so I humbly request you to please subscribe this channel, which also motivates me to come up with more technical content, right? So let's quickly begin with it once you did so. So Apache Web Server, and I'm very sure that you already have an idea about the web server, the basic concept of web server. So web server basically serves your content files, the web files. So let's forget about system design, only focus on the concept of web server. So let's say the moment you type www.somexyz.com, that it directly goes to some system, and then system is kind of web server. That web server takes up your request and gets some content files and send those files back to you via a TCP connection. All those things happens via a network, and then the fulfillment of request is being done by a particular web server. All right, so let's move on. So as I have already explained right here, that web server is a software that, or hardware, it could be hardware as well, that serves a content files over HTTP. So whenever I say HTTP or HTTPS, but understand that HTTP is the layer 7 protocol, but it works over TCP protocol, which is layer 4 protocol, right? So the way your HTTP works is, before making connection, let's say from your browser, you are trying to look through a website, right? And that website content is on a particular web server. The way this will work is your browser, which is client in this case, will try to make a connection to your web server, right? A TCP connection. Whenever I say connection, that means TCP connection. And then your web server will accept that connection and say okay. And then when the connection gets established, it will start sending all the data via HTTP to your web server, and the same ways as your web server will send the response back to your client, and the moment your browser receives the response, it will start rendering that response on your browser page, and you start to see your web files, right? That's how it works theoretically. Actually, that's how it works on the ground level. Let's do a deep dive into it. So if you look at the web server bigger picture, let's forget about that we are discussing about Apache Web Server. Let's think about web server. I already explained to you, right, that this browser is your client application. The moment you send this www.xyz.com, this request goes to your web server. So it first establishes a TCP connection with the web server, and then sends the data over HTTP to your web server, right? And then your web server can talk to your disk, right? And it might have the static files, or let's say as part of the incoming request, your web server can talk to your database and can talk to some other external service, right? And then it will try to generate, it may generate the static content, or it can generate the dynamic content. That basically depends on the implementation that you have done. And then it will prepare the response here and send it back to your browser. And as I said, the moment your browser starts receiving your data, it will start rendering it, and then that's how you see a content file on your browser. So that's how the bigger picture of web server works. That's a 10,000 feet level it works. Now specifically, since this video is revolving around the design architecture of Apache Web Server, we will do a deep dive into it. All right. So now Apache Web Server works on the same principle. Everything is same, right? So, and in case of Linux, it is also known as HTTPD. So when you start your Apache Web Server, it starts listening on a port, right? So let's say that particular port is 8, which is a port for HTTP. Now it will bind itself. So the way it works is, we will look to, so I have prepared few slides, right? If this is the final slide that we will discuss the whole request and response model, but let's deep dive slowly. So when you start your HTTPD, right, this Apache Web Server is a main process. It will get start in your local machine, or maybe your server machine. and it will bind itself. When I say bind, that will it will start listening on a particular port, and let's assume that particular port is port number 80. All right. Now it will keep on listening that port and wait for some incoming request to come, right? Now let's say there is an incoming request. It finds that there is an incoming request on this particular port number 80. Now it launches the child processes. Anyways, the child process, the creation of child process automatically happens, not during the receive of the incoming request. Now when you start your Apache Web Server, right after the starting, so Apache Web Server is working as HTTPD in your local machine, or could be, let's say, server machine. Once it starts successfully, it will spawn some kind of child process. That's how it works, right, in operating system. There is one main process. It will start number of child process. So let's say, and then those child process will keep on listening on this particular port. The core responsibility of this child process is to listen on particular port and serve the request, right? It's again very high level. We will deep dive into it, okay, how it's being implemented in Apache Web Server, all those fancy things, etc. But at the 10,000 feet level, understand that there are child processes, and the core responsibility of those child processes is to keep on listen on a particular port, and then if something comes up, it starts serving it, right? Now this whole process, whatever I explained, that listening on a port, and then once something comes in, a request comes in, you start serving it, right, and talking to database, talking to other services, getting data from the disk, static files, all those things are being controlled by a module. So that particular module is called npm in Apache Web Server, right? So all this information that I have gathered, you can find this information on httpd apache.org website. So this whole information, this I have not taken from any video or any internet article, because those articles have been also written by person like me, right? So we cannot trust on the authenticity of that article. So all this data is from the official website. However, they don't have the official document, right, because this is kind of contribution. So they have very vague kind of documentation, but it's I think enough documentation to understand the things at the ground level. So you can visit httpd.apache.org, and under the docs you will find all those things, right? So I've just consolidated the facts for you, as I did the same right in the case of the DynamoDB for AWS. Okay, so now, all right, guys. So as I said, this multi-processing module is an important component of Apache Web Server. And obviously you have multiple components as well, right? The configuration, for example, you have that httpd.conf file. So all configuration are text based, and then you have log files, then you have your virtual servers, etc., all those things. But the main focus area in this video is to understand how a request response model in Apache Web Server. Whenever Apache Web Server receives a request, how that works. So this is all the fundamental of system design we are trying to understand, right? Now let's try to understand what is multi-processing module, right? Let me go back to my next slide. So Apache Web Server, and the reason this multi-processing modules exist, npm exists, right, because there are multiple platforms. In order to make Apache Web Server compatible with the all platform, for example, you have a Unix like platform, you have Linux, right, you have Mac, which are kind of Unix based platform, then you have Windows, right? So for all to adapt with all platform, they have multi-processing modules. So based on the platform, it will automatically by default select one npm, or you can tune in accordingly. So that's what I have written in the first point, right? Apache Web Server comes with modular design to accommodate with wide variety of platforms. Now, as I said in the last slide, right, whatever happens, all the child processes listening on a port number, if some request comes in, and then serving that particular request, and then talking to all the other services, preparing a response and sending it back over to TCP connection to the client. This is all being managed by your npm, right? Now there are different kind of npms. prefork, worker, event, and for Windows there is MPA event. But let's say these are all fancy words. You don't have to worry about what is prefork, worker, event, kind of so and so forth, right? But the whole concept behind the working of MPM is the request and response model, right? And how that works is we'll discuss that in the next slide, right? Now I'll quickly explain you. So your Apache Web Server is a box. It's listening on a particular port number 80. So all the network traffic that is coming via HTTP is coming via 8080. Now that incoming request will be listened by a child process, and then it will take that request and send it to, for example, as part of your request, you want to make a call to database and then gather the user record, right? So this child process will go to your database, will try to get the data from the database and prepare a response. Now you see, I have been keep on using the word child processes, right? But that's not how it works at the ground level. The way it works is using threading. That's the concept of threading. So let's quickly move on to the next slide, right? So this is something where we will try to spend our much of the time for this video, because we have taken 10 minutes just to discuss the other things. So this is the request response model of Apache Web Server. So there is client, right? This client is your browser. Let's say it's keep on sending the request to your, this is Apache Web Server, this whole box, this box, the silver box. And then these arrows, right? These arrows, these are nothing but your TCP connections. So this is your TCP connection, this box. Because let's see how your HTTP works. In my other video, if you go to my video series and you search for how HTTP works, you will find a separate video on where I have only discussed that how your HTTP works, right? But I can quickly explain it to you. So the way it works is, let's say this is your client, right? This is our, so HTTP works on client and server model. You already know that, right? It's basically works on the client and server model. So the way it works is, client first sends a TCP connection to your server, right? And then server accepts it, and then it says it sends an acknowledgement, right? And then so I'm not going into very depth, just to kind of giving an introduction to you. So it will open a TCP connection, it will say accepted, and then it will start sending your HTTP content, right? Now when I say HTTP, because it works at the presentation layer, so you might be sending some JSON files, you might be sending some media files, right, etc. All those things will be working at the HTTP level. So you see, point number 1 and point number 2, there is another step involved in this process. So this all basically TCP connection established, right? Because this is layer 4 protocol, and there is another, for example, you have UDP in UDP, but you have, because UDP doesn't guarantee the delivery, right, via network. TCP does. So TCP is more reliable, everybody uses TCP, so your HTTP works over your TCP. So that is the reason I have said that you have these TCP connections, because internally it's mainly managing the TCP connection. Now remember, when the HTTP request comes here, it comes with the value of keep alive time. Now why does this Apache Web Server need keep alive time? Then that I will tell you in the end. So the way this architecture works in this model, in NPM, this model is, this kind of NPM is for Windows, and then this kind of NPM event NPM is for the Linux based, right? So the way it will work is, you have NPM, this, right, this bigger box, and then as I said, when you start your Apache Web Server, it starts as a parent process, the main process. Then when it will get a start, it will create multiple processes. So let's say those processes are your child processes. So this diagram I have created myself, I have not copied it. So based on the understanding that I have received, I have consolidated it and created this diagram. So now this child process will create fixed number of threads. So for these models, NPM and then event NPM kind of models in Linux and in Windows, it will have two type of thread pools. So one thread pool is only dedicated for listening for the TCP connection. One thread pool is for the worker threads, which will be dedicated for the work. So you have segregated the responsibility. Listener threads only have responsibility to listen. Once they listen, they will pick that request and move it forward it further to the worker threads. Worker thread will basically pick that request and then forward it to do all the processing and all those things, prepare response, send back to your listener thread, and then listener thread will send back response back to your client over to that TCP connection, right? So now let's go back to our drawing and try to understand the whole process. Now let me open this. All right. Okay. So you have your client here, right? You have your client here, and then this is your bigger box. So you may have your external services here, then services here, right? Now you have a thread pool here. So this thread pool is your listener threads, right? And then this is your worker threads. So this client will create a TCP connection first. It will create a TCP connection, right? So TCP connection has been established between these both parties. This Apache Web Server, and then the client, right? Is TCP connection established? It will now send its request via HTTP to your listener thread. Listener thread is keep on watching. So this whole traffic is coming, let's say, under port number 80, right? Listener thread is keep on listening on this port number 3. It will see, okay, there is an incoming request. It will take that request and pass it to the worker thread. It will take that request, pass it to the worker thread. It will take that request, pass it to the worker thread, right? So now worker thread will take that request. Now based upon the request, right, it may have to talk to your database, or you may have to talk to some other API service, or let's say you only have to get the record from your static files, right? These are the static files, right? So now it will prepare a response first here now, right? It will get all the data from here and then prepare a response here. Yeah. Prepare a response, right? And then it will send this back to your worker thread. Listener thread. Worker thread will send the response back to your listener thread. Now listener thread will send it back to your client, right? Now your TCP connection will get closed. Now you see, these are threads, this is thread. Now we cannot, so Apache server cannot keep on creating threads again and again for each TCP connection, right? So what it will do, it will maintain the thread pools. It will maintain the thread pools, right? Thread pools here as well. So it will create some n number of thread pools for listener, n number of thread pools for your worker thread. So whenever a TCP connection comes, whenever a TCP connection gets established, it will be dedicated to a listener thread, right? And then listener thread will take that request and then move it further to the worker thread. Now let's say all listener threads have already been engaged into the other TCP connection. If that request comes in, then that particular request has to wait for some time, because in your thread pool there is no idle listener threads available, right? So it has to wait for some time till the time our listener thread gets free and picks up that new connection, right? So the reason we call it request response model, because for per connection there is one thread dedicated, you have one dedicated thread. And same, the concept of threading also applies to your worker thread, and as we already discussed for listener thread, same thing applies to your worker thread. Now there is concept of keep alive, right? So now the point of keep alive, you see, now understand the problem with Apache Web Server. The problem with Apache Web Server is, for each connection, right, if there are three connections, let's say connection 1, connection 2 and connection 3, and there are 3 clients. For each client it will dedicate one thread, right? It will dedicate one thread. Now let's say now you have keep alive value is equal to X, right? And now let's say what happens, this thread goes to your worker thread and fulfill, and then worker thread prepares a response, and this sends back to your client to connect. This is client 1, client 2 and client 3. So this sends back the response here. Now then and there it will drop the connection. Now what happens if same client sends the request again? It's a web server, right? Maybe in your website you may be browsing and clicking on a login button, you may be clicking on the about us button, you may be clicking on the documentation button. So that connection, right after you are serving the request, you are dropping the connection. So that's again an issue. That's an issue of performance, right? That's how the performance will go down, because what you're doing is you keep on creating TCP connection, dropping it, keep on creating TCP connection, dropping it, right? So the reason you have keep alive is when you receive a request, you can ask to Apache Web Server that for this particular X time, please keep the TCP connection alive. I might send you the request again, so I will expect a response back from you as well, right? So for that particular time, if one thread is dedicated to connection 1, till the time keep alive time gets over, it will be dedicated to connection 1, and then will TCP connection will be persisted there, and then if there is a request, it doesn't have to create a TCP connection again and doesn't have to destroy the TCP connection again. So that's how it saves the performance. That's how you have the keep alive. So that is a part of your this event and then Windows based MPM multiprocessing module. So that's how your Apache Web Server works, right? For each TCP connection dedicates one listener thread, and each listener threads take up that request and forward it to the worker thread. Worker thread will prepare a response, talks to all the services, disk, static file or static files and disk basically, and or a database or some other service, network call, etc., all those things. It will prepare a response, send back to your listener will fulfill send that particular response to a particular TCP connection, a particular client over to that TCP connection, and everything will get over. And in order to enhance the TCP connection opening and closing, right, you have keep alive, and the use of keep alive is you don't drops the TCP connection till the time of keep alive, and during that time client can send the request and Apache Web Server can fulfill that response. So that's the internal design of your Apache Web Server, and that's how it works. Now there is one question. So you might have also heard of the term reverse proxy, right? So now understand what is reverse proxy. Now, so in this case, Apache Web Server is working as a web server and fulfilling all the content files related to the website, right? Using all these things that we discussed. Now there is concept of reverse proxy. I will create a separate video on the discussion and the implementation of reverse proxy separately, but just to make you understand in context of Apache Web Server, I quickly tell you, spend like 1 minute to make you understand. So reverse proxy is something, let's say you have multiple server 1 and then server 2 and then server 3 and then let's say server 4, right? So rather than client talking to each server directly, right? So these are nothing but your, let's say, web servers, right? These are nothing but your web servers. Again, web server. So rather than client directly talking to all these servers, what you do is you use let's say Apache Web Server in between, and then this guy knows that this particular request I have to route here, this particular request I have to route here, and then this particular request I have to route here, right? So this guy is acting as a reverse proxy, right? This guy is acting as a proxy for these services, and it's a reverse. It's taking your request to your servers and then sending the response back to your client, right? Now Apache Web Server, question 1 is, can we use Apache Web Server as reverse proxy? Answer is yes, you can. But is using Apache Web Server is the most efficient way of using as reverse proxy? Answer is no, because In the next lecture, when I'll be creating the lecture on Nginx, you will see that Nginx act as a best reverse proxy, because Nginx doesn't work on multi-threaded system. Nginx is single threaded system, right? So now the problem with Apache Web Server, if you see Apache Web Server, if you go here, right, and you see Apache Web Server is maintaining a thread pool, right? It's using a thread pool. Now problem with thread pool, if you see the concept of Apache is the proxy is this may be a single service, or let's say you will have another reverse proxy as well. But you see the main concept around the reverse proxy is it won't be in the n number of, you won't have the large n number of reverse proxy, right? And also you see the work of reverse proxy is to reroute multiple n number requests here and there, right? So there we cannot expect to have a delay in it. So for example, there are multiple n number of clients here, and they are keep on sending the request to get it served from the web server, and then all those requests are going via Apache Web Server, and you have one request, one thread, one connection, one thread dedicated. So you might end up have to a lot of resources, because you will have you need the maximum number of threads in your thread pool, right, in order to fulfill all these maximum requests, right? So in order to have your big number for your threads in your thread pool, you might have to increase your resources, right? And then when I say increase your resources, that means you need to horizontally scale your Apache Web Server, and vertically scale your Apache Web Server, my bad. Now whenever you vertically scale anything, you always end up having some limitations. You cannot keep on increasing your resources for any system. So that's the problem with Apache Web Server, because of the fact that it's multi-threaded and it maintains n number of threads in the thread pool. So for a heavy work like sending requests here and there, you might need a lot of threads, because there could be n number of connections coming in, n number of requests coming in over n number of connections to your reverse proxy. Then you need a stronger machine. In order to have a stronger machine, you need a lot of resources that you need to do the vertical scaling, but vertical scaling always have some limitations, and hence your Apache server is not a good candidate to use as reverse proxy, right? So that's the concept of reverse proxy with the Apache Web Server. All right. So now in this video, we discussed about what is Apache Web Server. We understood the basic overview the web server works, and we also understand the concept of main process and the child process, and this child process, how child process creates multiple threads, right, for listener threads and worker threads. And then we also understood that npm is something that controls all these listening and the working of all the threads, and then serving the request in terms of threads. And then we also understood that we have separated listener threads and the worker threads dedicated for different roles, for listening, and this one for do the operations. And then all these threads are being maintained by the child processes, and this comes under being controlled by your npm. So this is all npm, basically internal structure of npm, and that's how your TCP works. And that we also understood the point of keep alive. Why do we need keep alive? And in the end, we also discussed as part of this drawing that Apache Web Server can act as a reverse proxy. However, it's not a good candidate for your reverse proxy, right? So in the next video, we will create and we will discuss and do a deep dive into design of Nginx. So I will take some time to prepare the content on Nginx and gather and consolidate all the fact and architecture about it. So I hope you are liking my content. If you do so, if you are not subscribed to this channel, please do a subscribe to this channel and do a like. Thank you so much. Let's meet on the next video.